Okay, so the last chapter that we're doing together is called Sine Function, but it is going to relate back to some of the stuff that we've done previously in the school year. Things like domain and range, we're going to see them again. But we're also going to add on some other terms like period, amplitude, some of these things you probably have heard in other classes. Sine function is what's called a periodic function, which means it's a function that has a repeating pattern at regular intervals. Okay, so if you want to put next to periodic function there, periodic function is a function that has a repeating pattern. That repeats at regular intervals. So the first thing we do is actually identify whether something is a periodic function or not. If it's in a graph, it's fairly easy. You're just looking to see if the thing continues on its regular pattern. So things like sunrise and sunset over the year, it has a repeating pattern. We can predict when we think the sun is going to rise or when it's going to set, due based on our position from the sun and the season and those things. So there's things in nature that have regular repeating patterns at fairly consistent intervals, so we can predict things based on them. The definition of a cycle is one complete pattern of a function. One complete pattern of a function. I guess of a periodic function, because we want to make sure we're indicating it does repeat. So if we're talking about seasons, our cycle is a year. Okay. And then period is the horizontal length of one cycle. So 365 days would be the period for a cycle of seasons. So it's the length of a cycle. And then you guys probably have heard of amplitude before. Amplitude is the distance between the maximum and the minimum values divided by 2. So what's the highest, what's the lowest it goes, and what's the average? So it's the distance between the maximum and the minimum values of a periodic function divided by 2. So it's half the distance between the maximum and the minimum values. You'll see it in a graph, it's a lot easier to see. By the definition, it's like, ooh, what's happening here? Okay, so we're just going to look at a graph and we're going to start to analyze periodic functions. So this one is straight from your textbook. It says, how can you identify a graph that represents periodic behavior? The graph shows the predicted height of water at Hopewell Cape, New Brunswick during high and low tides for the first 7 days of May 2007, beginning at midnight on May 1st. How many of you guys have seen the high tides and low tides in New Brunswick? There's a dramatic difference between high tide and low tide. Like you can actually walk on the sea floor in low tide because it goes so far out. Yep. Yeah, it's really amazing to see the difference, and it's pretty extreme there on the coast. We don't really see our tides change that much. If you go to like the lakefront in Toronto, you might not see them change that much. But if you guys look at your graph here, it changes. So low tide looks like it's about 2 meters, and high tide is up by like close to 11.5 or so. Like that's a dramatic difference of meters. from about 2 to 11. So a difference of 9 meters. That's over 18, that's over 27 feet difference between low tide and high tide. Yeah, I'm way shorter than 2 meters, not 2 meters. Yeah. It does have to do with the moon. Yeah, so the moon pulls on the water. So if the moon is further, farther away from the moon, it's pulling it toward the moon. You got low tide. If the distance between the Earth and the moon is less where we are, then we have high tide. So it is related to the moon's position with the Earth. Okay, the first question says to describe the graph. Is this, first of all, a periodic function? How do we know? It's based on time. How else do we know? Okay, it is a function because it passes the vertical line test. Is it a periodic function? It does have a repeating pattern. It consistently goes up and down. Okay, so all of you guys were adding some different things here. Yes, so it's a periodic function. I like, Madeline, that you brought in some previous knowledge. It is a function because it passes the vertical line test, and it's periodic because it has a consistent pattern. Number 2 says the graph illustrates periodic behavior because it has regular predictable occurrence. Why are tides considered to exhibit periodic behavior? We just answered it because it has a consistent repeating pattern. Okay. Consider the portion of the graph from midnight on May 3rd to midnight on May 4th. So it's saying between times 2 and 3 on the scale. So we're going to look, I'm going to put a dot on the graph so we can see this. Okay, so time 2, which is here, and time 3, which is here. Okay, so I just looked at my time and went straight up and put a dot on the graph. Estimate the maximum value of the high tide. And this is an approximate because we don't have the exact number, but what do you guys think that looks like? 12-ish meters? It goes up by 2.5s. So, but it's skipping a line. So it's actually going up by 1.25. So above 10, you'd have 11.25, and then it's definitely bigger than 11.25. So we can say approximately 12 meters. What looks like the minimum value or the low tide? What's the smallest number you guys see? .3 or 2.2. If we say approximately, we're pretty close. Approximately 2 point, what do we think? 2, okay? Because we're looking at this distance here, which it's kind of hard to predict exactly where that is. What's the time between the high tides? So look at the 2 dots I put at the top. So each of the numbers on the x-axis is a day. What's the distance between the highest tides though, Josh? The 2 dots that I have. Yep, so go down, look on here. What's the approximate length of time it takes between those high tides? A day. It went from 2 to 3, so it's 1 day. Okay, the next one says, what's the time between the low tides? A day again. And if you looked at those 2 bottom lines that I drew there, it's just slightly past 2 and just slightly past 3. So it's about a day in between those. And what would be, part B says, what would one complete pattern of the graph represent? So one high, so actually let me show you here on the graph. We do one complete pattern. Just one, so a complete pattern or a cycle is one set of the repeating pattern. So what day exactly? It would be a day. If so, the way that I do this is I pick like any starting spot. So let's say I start up here and I'm waiting to see when the exact pattern repeats. So it goes down, dips quite low, it comes up, but not all the way to the top. It dips down, but not all the way to the bottom. And then I'm back up to the top again. So if you look at from start to end, it is a day. A cycle is one day. Has to do with the Earth's position from the moon. So the moon has gravity and it pulls on the Earth. Land isn't going to move with the pull of the moon's gravity, but water can move. So it can pull closer toward the position of the moon, depending on if it's where on Earth we are in our rotation of a day, because we're rotating on our axis, right? So depending on where the moon is, as we're rotating on the axis, it actually is pulling on the bodies of water depending on where the moon is. It is weird. Not enough to change anything. Yeah. And the wind actually is more about the Earth rotating and the temperature of the oceans and the wind. Number 4 says, give 3 other examples of periodic behavior. What do you guys think are things? It could be in nature or things you can think of. What has seasons? So sunrise and sunset. One more. So far, else has given us 2. What do you think?
Oh, actually, no.
Okay, I was being serious.
Yeah, we don't have a lunar calendar anymore, but there are consistencies with bodies of in space that we could actually say have periodic behavior. Yeah. Ooh, I'd have to look that up again based on the size of its orbit. I don't know. I come by my intrigue with math and science. Genetically, my dad used to actually have this Excel spreadsheet, and he would write in like the time of the sunrise in the morning, the time of the sunset, and he would do his own charts because he was always. My dad would do this. Because he was very interested in science and all of this kind of the patterns that you can happen that you can see in nature. He actually was an electrical engineer for General Motors. He used to say, if people asked him what he did, he said he babysat robots all day. Ooh. Okay, so this question says determine whether or not each function is periodic. That's our first thing, because we can't figure out if it has a period or a cycle unless it is periodic. So remember, we're looking for consistent repeating patterns. Josh. Okay, but does it have a consistent repeating pattern? So for example, that height of 2 on the y-axis, do you see that get repeated again? No. So is this a periodic function? No. Okay, so actually we're not going to go any farther. We're going to say it's not a periodic function, moving along. Okay, maybe in some ways we like that better. Six marks each just to say this is not a periodic function. Okay, so that one's done. It just is not, there is no repeating pattern. If I was going to follow this graph and look for something that's repeating, Here, I can start down here. I have a y value of -2. It goes up to 2, and then it's down to like -1.5 up to 1.5. I don't see the -2, +2 get repeated in the section of graph that I have. So I'm just gonna say it's not a periodic function. It's fine.
So for the next one.
Yep. Is it a periodic function?
Yes, like it keeps repeating. Like so first it goes up to 4, then it goes down to 1.5, then it goes up to 2, and then it goes down.
Good.
To, it keeps going up and down.
Perfect. So this one looks a little weird because you got like, looks like you go up a mountain, you come down, then you go up a teeny mountain, and then you go down into a valley. But then you're back up to the same high mountain, down to the teeny mountain, down to the valley. Okay, so there is a definite repeating pattern here. Because it is a periodic function, we're going to try to figure out its period, amplitude. Oh, and look, let's throw in for fun, domain and range from a long time ago. Okay, so period is the horizontal length of a cycle. So we got to look at the graph and figure out what do we think the period is. So we're going to do period, amplitude, domain and range. That's okay, we'll do it one at a time. Let's first look at the period. The period is the length, the horizontal length of one cycle. So for this question, I would just pick a starting point. So whether you're down here at 0 on the y-axis or you're at the top of the mountain, just pick a starting point and figure out when does the full cycle happen so you're back to that same starting spot. So let's say we're starting down here at 0, and then we go up to the highest point of the mountain, down up the teeny mountain into the valley. When am I back at 0? At about 6, whatever this is, 6 days. We're walking for 6 days. No. There's a little valley. Yeah. Yeah, so you're going up to the highest, and then you're going up to this teeny one, down into the valley, back to 0 again. But you're waiting for the full cycle. Yeah. Okay, so if that one doesn't, okay, so Madeline's saying it does cross 0 a couple of times. So if we're looking at 0, like that might be as confusing, then start at the top of the mountain. You're going to go down, you're going to go up the teeny mountain into the valley, back to the top of the mountain. So pick up a spot and figure out when the cycle repeats. Well, then you're looking at the horizontal length. So where did I start? What number is here? I think it's 2. I think it's going by 2s. And when did I stop? 8. So how long did that take? 6. And I don't know if this is days or what this actually represents, but the period is 6 units, I guess we could say, because I don't actually know what it represents. Madeline, if I pick the 0, I would get the exact same thing. Oops, I'm not trying to do that. Hold on a second. I'm going to erase this. So if I picked the 0, and I went here, and I went up, down, up, into the valley and back again, you're still at 6. You're at 0 to 6. So look at the difference between your starting and stopping values. Okay. Okay, amplitude is half the distance between your maximum and minimum values in the function. So let's look at this graph. What's my maximum value? Okay, and what's my minimum value? -3. Okay, so I'm actually going to give you guys an equation. If you look at the very end of this lesson, this right here is what we're doing. Maximum take away minimum divided by 2. You're looking for the difference, in math that means subtraction, between your maximum and minimum, and then divide by 2. So what is 4 take away -3 divided by 2? Good, it is 3.5. 7 divided by 2 is 3.5. So my amplitude is 3.5. Yeah. But you're, I don't, hold on one second. It's 4 here. Oh, actually, this is negative. Cameron, I think you caught it. This is -4. 1, actually, the y value is going by 1s. One, they're going by ones. 1, 2, 3, 4, 1, 2. It is going by ones. It is fine. Yeah. That was good to check though. Okay, guys, what does domain mean? Yes, you're looking to see if there's limitations on its X values. Is there any starting and stopping on this graph? It doesn't appear to. Now, it doesn't have arrows on the end, but it should have dots if it's going to say it's starting or stopping. So how do we say there is no limitation on my domain? Put it in math terms, though. What did you say? XER, do you guys remember this? I know, Elsa, it's so fun. So fun. Now, if I put dots on the end, if I put a dot here and a dot here, I want you to stop with the graph, but there is no indication of it starting or stopping. It just looks like it keeps going. It really should have arrows on the ends to show it's going, but it appears as though it's not ending. Okay, what is range? There are limitations on range. What's the smallest number? And what's the highest number? Good. It is going to go from -3 to 4. So how do I rate that? So start with your smallest number. It's been a while since we did this. Start with your smallest number. Y is greater than -3 and less than, oh, and equal to, because it exists there, 4. Y, so always start with your smallest number, put Y in the middle, and both of your arrows are going to be going to the left. Because this is saying that Y, sort of like this, whatever you guys are thinking this way. Okay, however you see that. The alligator mouth's like that. Because this is saying also that Y is greater than -3, but less than 4. So, okay. I never can think about it as a crocodile mouth. So just do that I just wrote up there, okay? That wasn't so painful bringing that back to memory from a long time ago, like January, I think, or February. That was a long time ago. So the new things here is period is the horizontal distance of the cycle repeating. Amplitude, take the max, subtract the minimum, divide by 2. Domain and range is previous knowledge to us. Okay, so let's look at this one. It's a little bit different, although you guys have actually already learned how to evaluate functions. You've already done this. We just have to have it in our head about a periodic function. Okay, so this graph is showing the relationship between y and f of x. I actually don't know what it represents, but first of all, is it a periodic function? Yes, it goes 2 to -2, 2 to -2, 2 to -2. So it's repeating. So it is a periodic function. The question says find the value of f of 0 and then determine 2 other values of x that also give 0. Literally all you're doing is looking on the graph. You're trying to find when your y value is 0. So I can look on the graph. F of 0 is here. Yes, Elsa. Yeah. That actually would be a value of -2. So hold on one second. You're almost there. So at f of 0 on the when you plug in the value of 0, you're going to be right here on the y-axis. Okay, you guys are with me so far? So I'm looking at my y value. It's at 2. So Elsa, when does that happen again? At what other values? Yes. It happens again here at -2, and it happens again here at +2. Okay, so let me just write that down. So f of 0 is going to be equal to 2. And it happens again at -2 and +2. So going back to evaluating functions from a long time ago. So f of x is representing your x-axis. Y here is actually representing your y-axis. So I'm looking at when x is 0, what is my y value? So I just look straight up the y-axis to figure out what my value would be if x was 0. Okay. Now they're asking you to figure out the value when x is 0.5. So let's look on our graph. Where's 0.5? And what's the y value at 0.5? What's the y value at 0.5, guys? 0, good. What other two x values would give you the same value? You actually have a lot to choose from. I have this one, this one, this one, this one. Madeline, so what are you seeing? A half, yep, positive half is the one that we first evaluated. So how about two other ones? Negative a half. And one more. And negative 2.5 or positive 2.5 or 1.5, negative 1.5. Any of those is fine. I'm going to put 2.5 in there. You guys actually have 1, 2, 3, 4, 5, 6 times it crosses the x-axis. It gives you the same value of 0. Okay. What's the domain of this periodic function? What's my limitations on x? That would be, yeah. Okay, good. Domain is all real numbers because you can see that this one actually gives me arrows on the end. So that's actually done better. So it is XER. There is no limitations. And also you already started range. What's my limitations on Y? Good. Yeah. Perfect. Very good, guys. Okay, so here's your short summary of this lesson. Periodic function repeats at regular, that's it, repeats at regular intervals. The period is the length it takes for the cycle to repeat. And amplitude is take the maximum, subtract the minimum, divide by 2. And then remember, we're throwing in domain and range and evaluating functions, which we can pull from our previous knowledge. Questions?